Hi, Toru. Nice to meet you.
Hi.
Good morning.
Hi, nice to meet you.
Yeah. So everything's good today?
Yes, I'm okay.
Okay,
I'm
nice.
good.
So I will have your slides on the screens and then your show time.
Okay. Good morning, everyone. Lei Ho, Hong Kong. I'm Wonyoung Choi, as known as Toru, and I'm working for OCBC Bank as a lead mobile developer. So I'm in charge of the product Frank by OCBC. Okay, today I'm gonna talk about a scalable and maintainable architecture. Simply, okay, here, what would be the reason why we come up with an architecture? Because at first we are only three, but as time goes by, our team have grown up and up. So nowadays we have up to 30. So we had to bring some idea up with the architecture to collaborate and cooperate each other. So, as long as everyone knows, well-formed architecture makes our work very easy, maintainable easily compared to not using it. So this is the reason. So this is a reason why I want to talk about. So what architecture do you use so far? Do you have any idea about this? What kind of architecture? For example, MVC, MVP, VBM, MVI, Viper, or RIPS, invented by Uber, right? But here from the architectures I cascaded, this is all about the whole architecture of an app, like a model or viewer controller or presenter or view model, whatever. But this topic is not about an architecture of whole app like MVVM or MVP or whatever which I just mentioned. Rather than that, I'm gonna focus more on data layer in app. By doing that, we can separate the UI layer and domain layer or data layer. And we can also looking forward to seeking some looking forward to separating all the logics and make it work separately. Okay, how have we designed the architecture? This is our structure diagram consisting of microservice, data source, repository, the domain manager, and presentation layer. Which is out of scope of this talk. Microservice means entity, and I also talk about the rest, like data source or repository. So microservice means the raw data from microservice. That means server side. We also define DTO. That means data transfer object for request or response. So this is the premise. We use retrofit and also its interface. We can look into more on this later. Next, data. Then the upper layer is data source. This is interpretation of raw value from microservice. That means, although I mentioned later on, we use model, request model, or response model, but our request DTO or response DTO are not as same as the request or response model. So this data source is in charge of interpretation or translation, so as to make it readable for the UI layer. So it returns success or failure response. And here that this is keyword ingredients of final response. Ingredients means that repository, which will be covered in the next slide, can have multiple data sources as per the needs or requirement. Here, we can see the request model or the real request model or response model that will be returned to the UI layer. Not only translating, but also implementing business logic is inside here. And one repository doesn't take only one data source, but it is able to take as much as data sources as much as possible to make some the response model done. So so code is like a pantry and the final food that we can eat. So the data source is like the ingredient or the set of ingredients. We can see more on the concept through the code later. If you have any questions, please feel free to leave in the comment. So after that, we have domain manager that will be exposed to the UI layer. By using domain manager, the UI layer or presentation layer can access to the response model or request model that is required for our purpose. A set of all repositories to be used for the UI layer. This is the summarization of the domain manager. Okay, finally, we can see the presentation or UI layer. So here the presentation layer can use and manipulate the data to render the UI for the users. This because this presentation or UI layer are fully separated from the other layer. So regardless of what change has been done in the domain layer, the other layers other than presentation layer, we don't need to care about this because the presentation or UI layer only looks at the final point of the methods we defined in the domain manager or repository. So from the coaxial pie chart, we can simplify right here with the familiar blocks like view, consisting of view, repository, or model, or data source, or entity. There are, we can see the same terminologies here that they are used for the previous slides: repository, model, data source, and entity. Here, entity means the request DTO or response DTO. Then in this arrow stands for the flow of the data or entity, and also represents the translation or mapping. So, okay, from here, we can see, we can look more into the structure or architecture I'm talking about. One premise is we use retrofit to make HTTP service and use coroutine, of course Kotlin, and dependency injection using Hilt. But in introducing and explaining the Hilt or retrofit, should be out of scope of this talk. But we can see more many articles from Google. So because Hilt has been released this year. The stable version has been released this year, but it was reintroduced last year in order to replace the Dagger, and not replacing, in order to simplify the complexity of using Dagger. Anyway, here, you can see into the microservice side. I want to define our API service handling card, because I work for bank. So this will be a simple example for this. Here, we can see the URL or request DTO and response DTO. We define RSDTO, RQDTO, and the method. And here we define the card data source and its implementation. And here, the base response is an arbitrary wrapper class used for HTTP response. API. Here, in order to elaborate, I would like to show the API result. By using the class, we can limit the scope of the inheritance of the class. This is basically a fundamental concept of C class, correct? So we have three cases of HTTP connection: API success, API failure, and API exception. When the API is successfully running, it returns data. It wraps the data into the argument of the class. So it returns the base response and RSDTO as well. So here, this is card repository. As you can see here, we can see our response model and request model as well as errors. Error for the response. I would like, in order to explain further, I want to show the implementation of the card repository interface. So as you can see, we are supposed to inject the card service. Card data source into the constructor, and also implement the card repository interface. So here, we can generate RQDTO based on the RQ model given through the argument, and also return the model for UI layer, which is response model. Here, we can put some business logics into the body of the methods, and also can get returned the API success, or API failure, or API exception. So UI layer only looks at this return result, API success, failure, exception, and can handle whatever user want to see, or whatever app wants to do on UI side. For example, if API is failed, then it will see the error screen or exception screen, or some screens saying, "Oh, this is an error. This is an error. So please retry." In this way, we can also implement the card data source implementation. So next is domain manager. Here, we are supposed to inject the repository instances into the constructor. So it simply by using this method, we can use the card repository, and also we can make it handle by the UI layer. What will be the advantage of using the architectural things? Flexibility. It means here. Okay, let me explain two things at the same time: flexibility and scalability. Here we can only expose the models and methods to the UI layer by using interfaces and its implementations. So although there are changes in implementations, but UI only looks at that endpoint methods. So UI doesn't care about what is happening in the UI in the domain side, even if there are some changes on the requirement due to the business changes. or we have to add more and more features into the repository layer. This way can ensure the scalability and the flexibility, because we can define a new component or modify the existing one. I mentioned together with scalability and flexibility. And next, this is the one advantage is maintainability. Since we have separated classes into layer like a microservice, data source, and repository, domain manager, and UI. So when we need to fix bugs, we can do it. We can fix the bugs component by component. If we can investigate where the bug happens. If so, it will be helpful for us to fix the bugs more easily than before, or other than not using the architecture things. So by using this, we can achieve some solid solid design patterns, design principle. I mean, so SRP, OCP, LSP, ISP, DIP, right? Single responsibility principle, or open and close principle, risk-off, substitution principle, interface segregation, or dependency inversion. But I would like to add quasi, because I don't think all the classes or all the components are fully separated to each other. Yes, by separating other components, we should be able to achieve the SRP, and by bringing the concept of using interface, we can achieve open and closed principle, and also we can also make our object in order to make other principles, and also by making make interfaces smaller and smaller, we can achieve ISP, the interface segregation principle, and other things. But we still have some couplings inside, so that's why I put quasi prefix at the beginning of the solid. Here, why I was making a slide, some idea just came up with. So I would like to introduce something. As you have been seen in the slide, the translating part or mapping part are still existing in the repository layer, and also need to map the data into the DTO from the model given. So by introducing the translator block here, so we can delegate the duties to the translator for the maintainability. So this is one of the enhancement part or advanced part for our architecture. Okay, this is the end of my talk. If you have any questions, please feel free to ask me some questions, or leave in the chat comment. Thank you.
Hi, Toru, thanks for your sharing.
Thanks for having me.
It's our pleasure. So any questions from the floor? People are quite shy, even they are behind the screens.
Because there was a delay in YouTube and Facebook stream, so
okay.
you probably have to
I see.
like for like at least half a minute.
Okay. Even then,
So
even we can consolidate the questions and let me answer if there's something.
Sure. Maybe I think maybe we can see Scalable. Okay. Maybe I can ask one questions first and see there are some follow-up questions from the audience. So you mentioned about like being scalable or like doing like a flexible architecture. So before, I mean, like what are the biggest improvement on Android that you feel like that without it you will never make the thing that you're doing today happen in the last few years?
Okay, this approach is the first one ever I had. So from the things ever I had so far. So in my previous company or other companies, we didn't have any proper architecture for the collaboration between the big team member. Cause my team was like a just small startup. Yeah, we have only 2 to 3 developers per each platforms. So we didn't need to take care for the architectures a lot. But once I joined this company, we had to adopt some architectures, because we have not only in-house developers but also partner companies. So we had to have some way to collaborate. Without collapse. Without conflict or collapsing in the code level. So far this approach works very well, but we are still actively refactoring the code.
Oh yeah, the code refactoring like sounds no much business gain like per se from the layman or the business perspective, but like like more and more code like no one's reading it, or like even like the engineers are gone. That actually can be quite an issue if we actually need to develop new features on top of it. So I really agree with what you've said. Like sometimes we actually wanted to do more refactoring and stuff.
Yes, exactly. But everything has pros and cons, right? But in order to adopt the architecture things, we every time whenever adding some features or refactoring, we have to handle or touch some classes as many as possible, like up to 6 to 7. So I wouldn't say there are only advantages, but of course handling multiple classes is also our effort.
True. Yeah, so it is actually a collaborative effort. Okay, so we have Philip asking a question. Let me pose Philip's question here. So let me repeat, like, will there be enterprise app architecture to govern all the apps, please? So basically, all developers can leverage and follow to scale their own apps.
There's a quote like, there's no silver bullet. So it really depends on how to define the work and business, and also need to put some effort to resolve in engineering way or developers way. So I wouldn't say that there will be an enterprise app architecture to cover all the apps, because every purpose is different for every person's. But so in separating classes as much as possible, and classes or packages, and classes into packages as much as possible will be a good practices or examples. Even for example, Uber uses RIB and also made it open source. Then because of the characteristic of Uber. So some of car hailing services like a Grab or some Korean company also poked in and manipulated to their purpose. So before, in my opinion, prior to find the architecture that governs all the apps, we need to define what our work are. I think that's the first one. App architecture is the next one.
Okay. That's really important because you can't actually have all the things in one place. So being able to decouple different parts is really essential skills or essential components to consider. Okay, so we got another questions from Andrew. How can I distinguish repository and data source?
Okay. Data source. Basically, one of data source is responsible for creating retrofit call and receive the DTO, the response DTO, and return to the repository. In the repository, after receiving the response DTO, there's a translator, and also need to manipulate from the raw data from server side to the type that is suitable for the UI. So for our case, we put some business logics into repository layer, but we are still thinking about how to separate as much as possible for our purpose.
Okay, good. Any follow-up questions from questions from Andrew? And Philip want to say thank you to the answer you gave just now. And I think thank you for Toru sharing. It's really insightful when we work. When the business grows, like the application will definitely getting bigger and bigger. So the ability to orchestrate different components to resolve the dependencies would be really the key to success. So hope you will join us next time, and then see you, Toru. Thank you.
Thank you. Thanks for having me. Bye bye. See you.
Bye-bye.
Later.